Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to a special KubeCon EU Office Hours session. Today, or this session, we will be talking about serverless and serverless functions with our Knative team. And I'm very happy to have the Knative team on. I don't feel like we've had enough Knative on the channel lately, so it's very good to have you all on. Josh Burgers is the one that actually organized most of this. I know he was just about to take a sip of his drink. So Josh, if you want to go ahead and do that, please do. And feel free to introduce yourself.
Hey, everybody. So I'm Josh Burkus. I am in charge of Red Hat community for all things cloud native. And that includes Knative and serverless stuff. Hopefully some of you just watched the serverless workflow spec session that just ended, and we are going to get into Knative and functions here, and we have here a good chunk of the Red Hat Knative serverless team. So if you guys want to introduce yourselves, we'll start with Roland.
Yeah, sure. So my name is Roland Huss. I'm based in Germany. I'm the OpenChef Serverless architect, and I'm also in the Knative TUC, Technical Oversight Committee. Yeah, and on Knative itself, I'm also working on the client part itself. And yeah, that's me. And I hand over to Zbigniew.
Hello, everyone. My name is Zbigniew. I'm based in Czech Republic in Brno. I'm engineer working in OpenChef Serverless team and more specifically on functions part. And I'm as well a maintainer of Project Kata, which is something a little bit different.
Ooh, cool.
And I hand it over to Luke.
Hi, folks. My name is Luke Kingland. I'm based in Tokyo, and I'm also working on the functions aspect of OpenShift, along with Roland and Zbigniew.
Wait, what time is it where you are?
Right?
Late.
Yeah. Okay.
Actually, I'll just introduce myself as well. I'm the random extra person in the room, so I'm the marketing person. So I'm Simon Seagrave. I'm the product marketing manager for OpenChef Serverless, and I'm here to support the team as the questions come through. So please engage with us, ask some questions as Roland, Zbigniew, and Luke go through today's session. Would love to hear from you.
And I understand you've got some slides to get people started here.
Yeah, sure. So actually, we have some slides prepared for you. So there's some introduction into Knative, I think, just to warm up. And then we will go into more details about the different components of OpenShift Serverless and Knative, and especially on functions. So this is kind of a new thing on top of that. I think this is also super exciting. So let me share my screen.
I believe. Yay.
Yeah, it works. That's good. Yeah, so let's talk about serverless. And by the way, if you have any questions, also, of course, I have, please ask immediately. We will also try to make this session as interactive as possible. So just ask and we will stop for and answer your questions. But let's start about serverless with Knative and Kubernetes. So first of all, what is serverless? You probably know that guy, and you probably also know what CGI bins are if you're a little bit older like me. And of course, this guy here has a point, actually. Is it really more than just a CGI bin that you throw over the fence and then somebody is operating your CGI bin? In some sense, this is true. But actually, I think we can show you today that serverless is much, much more than the good old CGI bins. And that's the gist of this talk here. So we will talk about serverless, but we'll also talk about functional service. And there's often, as you know, serverless is really kind of a very fuzzy term. There's a lot of buzz around serverless. And if you ask 10 people about serverless, you get probably 12 different opinions about what serverless is. And so we came also up with kind of a definition. So this, I don't mean this is the whole truth. It's something that we use as our definition. And we also make a distinct difference between serverless and FAS. This is functions as service. So for us, serverless is really a deployment model, which means that you abstract away the whole infrastructure which is running your application, like for the good old CGI bin, where you really do not care who's running your CGI bin. So it's really about a deployment model where the servers are not visible to you, which means you also don't have to manage your servers. And so you can really have a fine-grained billing model. So it means that you can only have to pay for what you really are using. So pay as you go, so to say. And I think this is one of the main benefits if you want to use serverless. And it also uses a deployment packaging. So in our case, this is a container image. So this, but there are other serverless architectures out there, like for AWS Lambda or Microsoft Functions, that have a different, different deployment format. So on the other hand side, there's a functions as a service, which is a programming model which builds on top of serverless. So functions as a service also, so functions get deployed with a serverless model, but it allows you to have a higher level abstraction how you create your application. So like there's a kind of a function signature that you need to fulfill, and then you just hand over the function itself without any other runtime. And so it also adds you, in the context of Knative, it also adds the build aspect to the system. And it's typically used for glue code kind of applications where you connect services together in a glue way. But actually that we have also some a little bit more detailed definition. So maybe Zbigniew, you can talk a little bit about the finer grained differences between serverless and
thank you, Roland. I just want to highlight what you just mentioned. So basically, how do we look at the serverless in Red Hat and functions? So if you have your container with your application and you just want to make it serverless, so we call this serverless containers. So basically, you can just package your container as a serverless container with Knative. So it can accept cloud events, it can accept HTTP requests, and all the application code needs to be developed by you, or all the incoming handling incoming requests, etc. But on the other hand, the functions provides you with some glue, with some logic that basically is managing the handling of the incoming events and incoming requests for you. But in the end, the function itself is packaged and deployed as a container. So basically, both approaches deployed on the cluster are behaving the same way, but it's really the matter of the packaging and on the setup and on the glue of the functions, for example.
Yeah. So this is really about this is kind of a general remark about serverless and functions. Now let's to set the context right. So let's have a look now to what is Knative actually. So Knative is a serverless platform where you can run and operate your applications in a serverless way. And it's really, as we mentioned, it's really a deployment model. So it's Knative is really the platform underneath that model, which allows you to deploy and manage modern serverless workloads. So this is the kind of the self-definition of Knative. You find that on the web page for Knative itself. And Knative actually consists of two components. So there are two major components there. So one is called serving, the other one is called eventing. And serving is all about a request-driven model that allows you to run your containers in a very simplified way, and it allows you to scale your applications automatically based on the load that comes to your service. And this includes also scaling down to 0, which means that if your application is not used at all, you don't have to pay anything for your application to be deployed. I think this is one of the big things with the serving component. And on the other hand, there's also eventing part, which provides you a common infrastructure for consuming events from external sources to route them through the system and maybe eventually add up at a Knative service, which reacts on events from the outside. So it's perfectly suited for EDA type of applications or event-driven architectures-based applications like that. So this is the high-level view on that. But I haven't really talked about what Knative actually is. So Knative is an open source project which has been started in 2018 by Google. And it's a community-driven project which is has a lot of vendor backing. So there are big companies which behind Knative and supporting and sponsoring Knative development there. But actually, it's open, totally open for the community. You find here the coordinates for the project on the slides. So the code is on GitHub. There's a dedicated website for that. And actually, as I mentioned, there are big companies like Google, Red Hat, IBM, VMware, and so on that are supporting Knative. And recently, in the last year, some changes happened for the governance. So actually, we have different, a very open governance, which is a little bit similar to Kubernetes, but so it's similar, that it has similar kind of committees, like a steering committee and a technical oversight committee, which is for the general direction, more for the technical direction. But it's not. It's important to mention that Knative itself is not based on a foundation, so it's still kind of a project which has a trademark and a brand, and this trademark is still kind of owned by Google. But actually, we have also there's also now a trademark committee which deals around with all this trademark and brand related issues, and this seat is given to the biggest contributors to the project. Otherwise, there are multiple working groups which meet regularly, and they are working on certain aspects like serving, eventing, but also for the client and other stuff like here. We have a 6 weeks release cadence, and the current version is 0.22, but we are working hard to get 1.0 out this year. And actually, all of the work that we are do currently is really focused to get to this 1.0 version. And the next question might be how you can try out Knative. And actually, there are several options, of course. So you can run Knative, of course, on any Kubernetes cluster. I forgot to mention that Knative itself is based on top of Kubernetes. Of course, a very important thing, but sorry for that. But you can run it on any vanilla Kubernetes cluster. So you can run a Minikube on Kind. You can run it in the cloud on any Kubernetes offering. How to do this is described on the Knative website. But there are also commercial offerings that you get really support for that, where these systems run Knative workload payload for you. One of them is IBM Cloud Engine, which allows you to run Knative services directly into the cloud, like you can do with Google Cloud Run, which is running on GKE. So these are really public cloud offerings. So where you have kind of a virtual cluster Knative installation, and you don't have to worry about the management. And then we have Red Hat OpenChef Serverless. This is the project that we are working on. And this supports all Knative features. You can run this really in different ways. You can run it on-prem, you can run it in a managed way in the cloud. So you have really this kind of all these hybrid cloud features there. And you can get full support. So you have really plenty of choices that you can choose from to use Knative or trying it out. So I think every of these offerings have also a free tier, so you can try this out as well directly. Good. So this is actually kind of the introduction to Knative itself. Are there any questions until now about this kind of overview before we dive into more details?
There are actually a bunch of questions from all kinds of things. One of which I don't think we can actually answer. So
yeah.
And of course, some people came here already being Knative users with technical questions. One of them actually wants to know, and we might want to follow up in chat. Wants to know actually how to enable auto TLS in Knative, because they've had a lot of trouble doing that. They say. Config cert manager, config map doesn't seem to understand Knative functions or events.
Yeah, so actually this is a good question. So Knative itself does not have any TLS related features intrinsically. So this works together with some external services like with Istio. So you can enable TLS like features like MTLS, for example, with leveraging service mesh for thing. But otherwise, I think so. TLS should be supported directly. So there is documentation around that. So maybe if this is a very an issue with that, I really would like to ask you to come to our community channels, which is on Slack, or open a GitHub issue on there. We are there to help, and because it's hard to analyze it. But in principle, we have this kind of features here as well.
Where's that community channel? We'll go ahead and put it in chat.
Oh, it's on CoreOS, sorry, Kinetic.dev Slack. Sorry, this was wrong. Kinetic.dev. So actually, we can paste it then in the chat as well.
Yeah.
So somebody could do that.
Next question is, does the serverless containers in Knative have built-in auto scaling, or do you need to also add an external load balancer?
Good question. So yeah, actually, I don't have to answer all the questions. Spinning or Luke, if you would like to answer, but I can do also answer it. So jump in. So actually we have auto scaling intrinsically in Knative, so because it's one of the core features actually. And the good thing is that this auto scaling is based on consumption. So it's not so much like the horizontal pod auto scaler from Kubernetes, which is by default based on CPU and memory consumption. But actually, Knative itself is a very sophisticated autoscaler. We will see them in action in a minute when I'm going to the demos. And this is really counting concurrent traffic by default, and looks and scales are based on concurrent traffic, which means it really counts how many requests are in flight, and then depending on the number, depending on the configuration that you have chosen, either scales up your pods if it's higher than a certain threshold, or even if after a certain amount of time no traffic comes in, then really scales down the number of replicas for your application to 0. Yeah, so long answer to the question. And the short answer is yes, of course, we have auto pods.
Roland, just a really quick question. One we get asked all the time around this. Obviously, one of the real key value propositions of this is the scale to 0, which from an infrastructure person's perspective is great because it frees up resource, so you can oversubscribe your hardware, sweat your hardware a little bit more than normal. In the real world, with your engagement with customers and what have you, that auto scale functionality, are you seeing, how many people are you seeing out there actually leveraging that scale to 0 versus maybe scaling back to 1 or 2 instances? Are people adopting that new capability?
Yes, actually, I think this is one of the key features why people are really trying to use it, especially because when they have an overall very inhomogeneous traffic shape. So like a burst traffic, which happens. So let's imagine you have a Christmas card shop, which only sells a Christmas card at Christmas and not on the rest of the year. Then of course it's super awesome if your application does not sleeps for, let's say, 11 months and then fires up in the last month. So this is an extreme example, of course, but you got it. So if you don't have a constant traffic shape, which means constantly flowing in traffic, then it's super convenient also to scale down to 0, which is, for example, especially useful for startups which want to minimize the risk for the costs, for example, so that you can try out things, and if it doesn't work out, it just don't cost you anything. So I think this is one of the big key features here.
Yeah, and I would like to highlight that basically, if the deployment is scaled to 0, you don't have to be afraid that your incoming request to this scale down service is lost, because Knative basically holds the request and scale your deployment to 1, and then forwards the request to your application. So no requests are lost during the scale down phase.
Awesome.
Well, we're getting some other questions, but I think some of them are stuff that you're going to have in these slides. One thing I will interrupt and say, actually, because somebody's asked this a couple of times, it's a question we're not going to answer. Somebody was asking questions specifically about the Google Cloud Run, and we this is the Red Hat serverless team, so we can't actually answer questions about Google Cloud Run. We just don't know. That's their thing, and I'd encourage you to attend a Google Developer Relations session where they can answer those questions. So if you want to go ahead and continue with this, and we'll pick up more questions.
Let's talk about serving. So actually, as I mentioned, serving is one of the core components of Knative, and it's really about routing your traffic to your application, then scale to 0. We already talked about that a bit, and also to have revisions, which means that you can have snapshots of applications and that allow you to roll back, and also to split your traffic among different versions of your application. We will see this also in a second in the demo. Yeah, what are the concepts? So actually, as mentioned, it's really demand-based autoscaling, which means that it's really based on the real traffic that gets in, and so you get a really direct relationship between the usage of your service to the resources that it consumes. So the number of pods that are running. It separates the code and the configuration. Of the code, of course, is in the container image. The configuration is what you define here, and also that the configuration is really kind of snapshotted like here. And it's kind of opinionated. It's actually this sorry, the slide are a little bit older, so some of the restrictions already be relieved. So actually this so one of the big restrictions is still that it needs to be a stateless application, so that you can have this kind of high dynamical autoscaling there, but actually you can have multiple containers within your Kinetic service these days. Then it has also rich traffic split capabilities, which means that you can enable custom rollout strategies like canary deployments and blue-green deployments. And this is super convenient because you have different versions of your applications running there. And then you can really fine granularly define how many traffic goes to which version. You can try it out and then scale it forth and back as you like. So all the kind of missing strategies from Kubernetes, core Kubernetes, you can have this with Kinetic as well. But one of my main, so actually this is how it looks like in code. So Kinetic itself is implemented with CRDs on top of Kubernetes, so it uses the Kubernetes extension model. Then you have the high-level service object CR custom resource that is exposed to your user. And with this, you have kind of implicit objects that are created on behalf of the service. So the route configuration and revision are typically not created by the user or not exposed to the user. Of course, although the route, for example, could still be available to create on your own. But typically, the only interaction with Kinetic is through the service. And as you see, the revision is kind of a revision history, and the configuration itself is really the head of the revision set. So anytime you change the configuration, either via service or directly, then a new revision gets created for you on behalf by the backend controller. Okay, but I think one of my favorite things is really here is that it's really, in addition to all these benefits, it's really also a simplification of the deployment model itself. So now here you see a classical Kubernetes deployment for a very simple application. You see you have tons of YAML file, which is quite huge. You need also, besides this deployment, you need also a service in front of your deployment, Kubernetes service for that. And then if you want to access it from the outside, you need an ingress. And now compare this to the actual version of Kinetic. Again, sorry, it's an older slide. It's already, of course, V1, the API version. This is my bad. But actually, you have also a service. Unfortunately, it's also called service. I think this has historical reasons, but it's not a Kubernetes service. It's a Kinetic service. So the kind is the same, but the API version is different. And then you can omit all the other things which are here in very light gray, like the number of replicas, the selectors, and the name of the container. And this really shrinks down considerably. And you do not have to specify all the other resources too. So I think it's now time to demo. And actually,
okay, wait, before we get into the demo, can somebody, because of some of the questions, we're getting a lot of questions from people who are new to the whole concept of serverless. Okay. So does somebody want to give the 2-sentence elevator pitch of what you would want serverless like Knative for, period? Just the 30-second, because it looks like some people are lacking that.
Okay, so the thing is that it allows you a simplified deployment for your applications, that you get a flexible auto-scaling based on traffic. And we will see it with eventing. You have also so it's a perfect platform for creating event-driven architecture-based programs. I think this is that. So actually, it's really about, you don't have to really to worry about, for example, a number of replicas that you want to have for your application. This gets auto-scaled automatically, and this is, I think we believe that the Kubernetes, the Knative autoscaler is a directer approach to autoscaling than the horizontal pod autoscaler from Kubernetes.
Okay.
Yeah, I just want to mention that the difference between the HPA, which is in Kubernetes, is basically that HPA by default scale based on the CPU and resources. So, for example, your application is consuming a number of memory and some number of CPUs, but some deployments needs to be scaled based on the incoming traffic. So this is where the Knative autoscaler is different. So it scales based on the number of concurrent requests. So this is beneficial for a lot of deployments, I would say.
Yeah, and there's the clue in the name there. Actually, the auto scaling. You don't need to worry about take into consideration about how you're going to scale your application up and down. It's all handled for you, which is pretty massive, which is great from a developer's perspective. From an IT ops person's perspective, where the real nice, again, resource underlying infrastructure savings there. If you've got all this state of applications or serverless applications that are scaling back to zero, obviously they're not running concurrently all the time. So there's massive infrastructure savings to be had, resource savings that is to be had when you're scaling these apps. Back to zero and up as needed as well.
Okay, let's go ahead and go to the demo. Hopefully that'll also give people.
Yeah, actually, this is, I think, I hope it makes clear in the demo. Actually, this also shows you that it comes with a quite decent developer experience for Knative. So actually, it's also made for developers. So Knative is not only for operation that you can save costs, but it's actually one of the main focuses really to make it easy to get your payload, your applications onto the cloud. And I hope I can make this clear with the demo now. So what you see here is I'm using here a command. On the top of this of the screen, you see a watch on the number of pods that are running in the cluster. I'm running against an OpenShift cluster in the cloud, which has OpenShift Serverless installed. So one of the product based on Knative, but actually this is just pure Knative itself. So everything I'm showing here works perfectly fine with a pure Knative installation on top of Kubernetes. So what you see, I'm leveraging here a CLI, which is called KN. This is the Knative CLI. But please keep in mind that everything what I'm doing now with the things on the demo, you can also do as well with YAML files itself and kube control, for example. But actually, this KN gives you a really nice user experience. And what I'm creating now is a service, and the only thing that you need to provide as parameters is the name of the service and a reference to a container image. And in this case, example, this is a very simple REST service, which is just generating random numbers. So it's just, when you curl it, we will see it in a second, it just returns you a random number. The application here itself is based on Quarkus, which is a Java runtime framework, which allows you extremely fast startup times and extremely low memory overhead. This is also done by Reddit. And you can use Quarkus, is really super amazing. But actually, there are probably tons of other talks about that. So sorry. So let me create that. You see that actually with this CLI, you wait synchronously until the service is up, and you see it at the top that it gets started. You see also that this goes very quickly. And now you have running this on your cluster. You get automatically an ingress created for you in the service net, and you get out the URL here. And of course, you can just use curl. I'm just using this URL and put it into JQ for formatting issues, and you just get back here the a random number, and you see the numbers. So super sophisticated service here. Okay, so you have running all the service, and now if you wait long enough, and if I do not send any CRUD, then you will see that this pod gets scaled down to 0 again. But to make this a little bit more quicker, so I'm making an update on that. So I'm just I have also an update. So what I'm doing here now is that I'm updating the current service. And then I'm setting some autoscaling parameters. You have tons of autoscaling parameters that you can use to influence the way how the autoscaler acts. In this case, I say that I want 10 concurrent requests at maximum, which means after one pod serves 10 requests, then another pod gets scaled up to serve the other request. So if they're roughly, this is really roughly because there are some other parameters like a burst capacity, but I don't want to into much detail, but roughly if you have this concurrency limit, 110, and you have 100 requests coming in, then you get 10 pods, which serve these 10 requests. And then I have also another parameter, which is called autoscaling window, which is just the number of time which is used for calculating metrics. And actually, in our context, it means if there are no requests coming in within 6 seconds, then the pod will scale down. The default is 60 seconds, and you see already in the top here that the pod is going to be scaled down because I'm talking so much here. Okay. And then I'm adding here some environment variable, a delay of 1,000 milliseconds, sorry, which means this has a meaning for the application itself and just means that the request, there's a sleep for 1,000 seconds while processing the request. This is important to show you the upscaling behavior. Because otherwise, if the request is too short, you don't get to a concurrency of 10. Okay, let me do the update. And you see for every update, you get, again, a new deployment. It's just to verify that the update really works. You can look in all the revisions that are there. And here you see that the original one was revision 1. Then a new one is created, which is revision 2. And this revision gets all the traffic here at the moment. And if I'm going to make a curl, I get just a new version, but actually I'm trying to run now a mini load test on that. So hey is a CLI command, which makes, in that case, 50 concurrent requests with that. And let's see what's happening now. If I'm running that, you'll see that immediately tons of containers are really scaled up. And this is something also you have seen that it's not something that it's one after each other. There has been multiple pods span up immediately together. And this is because there's a very sophisticated way how to detect called a panic mode, which means if the increase of requests are very quick, then you just create more pods in advance. So in anticipation that there are more pods than only that you get more requests like that. So yeah, but actually I think I already have shown you the key thing. So I have something more, but actually I think I'm already a little bit late here. So, but you see also that now when this is done here, then all your pods going down after 6 seconds when no traffic comes in. Okay, so this was the serving demo. Actually, I could also, of course, you can also describe your service here. Directly you can, sorry, it's service described, what got it wrong. And you get all the information, you get the URLs, you get the split. So you can also split the traffic among different revisions. So I could split between old and new revision there. So, but actually, let's stop the demo here.
This is great, Roland. Your Christmas card shop is meeting demand. You're not losing any customers. Yeah. You've scaled out. So yeah, brilliant.
Yeah, there's of course one caveat because this code introduces a latency. So if you start from 0 to 1, you always have to wait until the first container starts up. This is so-called cold start latency, which is always kind of a problem. We try to minimize that. So this cold start latency has different components. So one is, of course, the application itself. It needs to be started fast. This is the reason why we use Quarkus, but because Quarkus is super fast. So if you look into the logs or if you measure it, it's really in below 10 milliseconds. But then you have also other overhead like the kubelet starting the container image. Then you have the scheduling process and so on and so forth. So it takes a little bit, but it's more in the second range. Okay. Sorry that. So this was the demo. So actually, if are there, Josh, any questions around the demo? So actually, you're on mute, I think. Josh, I can't hear you.
Mute.
How did that happen? Okay. We have quite a few questions queued up. And I don't think they're necessarily related to eventing. But a bunch of them are related to scale up and scale down.
Mm-hmm.
One first thing is a sort of general conceptual, couple of general conceptual questions. And I'm going to start with the sort of biggest one, which is people are not understanding the principle of scaling up and scaling down a serverless thing. That is, when do you get additional instances and when do you not? they're kind of thinking about it in terms of HPA.
Mhm.
And I know it works differently. So do you want to explain that? Like, when do you get an additional serverless container, say?
Yeah. So the difference to the HPA is that that the HPA, so you can use the HPA with custom metrics as well, but by default you're using CPU and memory. But CPU consumption and memory consumption are more like indirect measures of your traffic. So has the assumption that if a traffic comes in, that your application uses more CPU when you have 10 requests compared to 1 request when it processes them simultaneously. The same is for memory. So, but the scaling trigger, the scaling event for the HPA really goes on this kind of indirect metrics, which of course gives you not so deterministic behavior like you have if you really scale based on the actual number of requests or the duration of requests. So in this case is really concurrency, which means parallel request in flight. And so the autoscaler is just, I think it's more suited really to maps directly to the traffic and to the load that you have. And of course, if you think a little bit further, also maps to the revenue you get, because the more users you have in parallel, but this of course is a little bit far-fetched maybe. Yeah.
So a follow-up on that from Slack is we've got somebody in Slack who works in telco sector, and their concern about using serverless is delay to basically start up a new container when you're auto scaling. Is that something you can talk about in terms of latency and that is a workloads that are latency sensitive, and how you'd handle that for serverless auto scaling? Yeah,
sure. So actually, you have. So I think we are aware, but actually, Spinnik or Luke, if you have any ideas about it as well. But actually, I think the one thing that you always can do, you can set the min scale to 1, which means that you just prevent scaling to 0. Of course, you lose some benefit of saving stuff, but if you know that you will always be with traffic, and that it's super important that you have a very low latency for every request, then you set the min scale to 1, and then you have always at least 1 pod running for applications. So we can avoid the cold start issue altogether with that. But then we also try to improve the cold start latency on several layers. So we're looking into Kubernetes itself. For example, there's a very concrete example, very specific example, that there are certain triggers within the kubelet which probes for every second something, but of course, if you probe every second, you cannot get to sub-second behavior. So this is one of the things what we look into, but we also look into more things how we can improve Kinetic. But at the end, we must be clear. So it's a container-based system, so you will always have an overhead which is probably still higher than you would get for proprietary systems like Lambda or any other stuff which do not use containers. But on the other hand, you have the whole benefit of container that you can run everything in the container with serverless on Knative, but not only specific stuff where your API is suited for. Lambda, for example, there's only a handful of programming languages that are supported, but actually with serverless, you can provide everything. So actually, we are aware of that. There are some answers how this can be improved.
The other thing as well to point out is really comes down to the underlying application, how it's been developed. I mean, an application that takes 10 seconds to start, for example, relevance is always going to take 10 seconds to start. So that's why you really need to look at your development of the application. And Roland touched on it there before, actually. Yeah. I mean, at Red Hat here, we've got the Java runtime framework, which that was built with these, with this in mind. A lot of it is low memory footprint and also very fast start times. So, if you've got that older legacy type application that does take maybe 10, 20 seconds to start, even in the serverless environment, it's still going to take 10 to 20 seconds to scale up and start. So that's why you've got to start looking at the development of these applications with speed and performance in mind as well.
Sure. You definitely do not want to start a WebSphere in a serverless application.
And you can also be a little bit conservative on how you define the concurrency level, right? So if you need there always to be overhead for your ability to answer requests quickly, you can set an aggressive concurrency target that starts spinning up those new service instances far before you hit the limit of what the currently running services can handle.
Yeah.
Here's actually sort of a bigger concept question, which was, we have somebody coming in who's actually familiar with Amazon Beanstalk. And they wanted to say, can somebody compare sort of work dispatch and load systems like Amazon Beanstalk to Knative and Kubernetes serverless? Do these fulfill the same function? What's the difference between the two, aside from the fact that Beanstalk is VMs and Knative is going to be containers?
Yeah. To be honest, I'm not really knowledgeable about Beanstalk. I know it, but actually I cannot make a qualified answer here. So maybe somebody else want to. So actually, sorry, it's just I don't want to tell something wrong here.
Yeah. Luke, Zbigniew?
No, I get that. Yeah.
Yeah.
Okay.
Okay. So maybe we continue, but actually one question to Zbigniew now. It's because I have eventing, I think we only have only that many minutes time. So maybe we can just start with functions first and look on the eventing, or I think this would be
yeah.
Because I think function is super exciting and it's really super interesting and it's a new thing. So I really would hand over now to Zbigniew for that.
Okay. So can you actually scroll the slides to the functions part?
Yeah, I can do. Let me scroll the slides. Actually, we come back to the event sources, eventing when we have time. But actually, I just want to let's talk a lot about eventing because we have also quite nice demo around that.
Yeah. So around let's say describe the Knative, the two main parts, which is the serving and eventing, and we are building on top of that because we would like to provide extended, let's say, developer experience. So with plain Knative, you still need to create the container on your own, still need to package it and do the deployment. But with functions, we would like to get rid of all of this stuff. So we would like for the developers just to write the business logic and very simply deploy this function. This function gets deployed at the end as a Knative service, so it can benefit from all the Knative service, from the auto scaling, from the configuration, or from the eventing part. So our function stack is based on CNCF build packs. So if you are not familiar with build packs, it's a cool technology. So I recommend you to check it out. So basically, very shortly, it allows you to package your application and create an OCI image from your application. So there are, let's say, builders and stacks, where you define the type of your application, and the build pack is then doing the inspection of your code, and based on the actual application, based on the language, it builds the application and produces the image. For our functions, we support currently Quarkus runtime, Node.js, Spring Boot, and Golang, and we are releasing Python support very soon. This is the functions are opinionated. So basically, we provide you with a function template where you just need to implement your business logic, and then we are calling the build packs to package your application and deploy this as Knative service. There is one more important aspect, which is that each function can respond to HTTP, which is the plain HTTP requests, as we saw with the serving demo, or it can respond to cloud events. I suppose that Roland will be talking about cloud events later in the eventing section, but basically cloud events are a specification where you can basically it's a wrapper around your arbitrary data, and they are specified in a unified way. So you have this kind of wrapper, the cloud event, which is some metadata and the data itself. So then you can send the data in the system unified way. So you have components that understand cloud events, and they don't really care what's inside the data. So you can, for example, have a Kafka connector which listens to your Kafka topic and converts the Kafka message from the Kafka topic to the cloud event, and then it can be sent through the system unified way. The same for other services, right? Redis, or I don't know, whatever else can come to your mind. It's very simple specification. So our function can respond to this cloud event as well. So this way we can enable, let's say, real event-driven architecture and development. Roland, if you can go to the next slide.
Actually, let me interrupt you with a really quick question related to this. Somebody actually wants to know whether this supports Kafka versions 2.5 and higher.
I'm not sure from top of my mind what's currently supported version of Kafka in OpenShift, but basically what's OpenShift Serverless is by default. You can install it through the operator hub in your OpenShift instance. So whatever is in OpenShift, it should be supported, if I'm not mistaken. So to really enable the developer experience, we have created a plugin to the KN CLI, which Roland showed before. And with this KN CLI, with this Funk plugin, you can manage your functions, you can build them, deploy, etc. So maybe I'll show the demo for now. Okay. So let me actually share my desktop.
Actually, while you're doing that, Zbigniew, just to mention to the folks out there, this is currently in dev preview.
This is currently dev preview.
Of OpenChef Serverless, soon to go into tech preview. So.
Yeah. So this project is not part of Knative, but we are building on top of Knative, and this is obviously as well open source project. So as I mentioned, we developed a Funk plugin on the KN CLI. So as you can see, we can do several stuff. So actually, let me just quickly create the same application that Roland did before. So to print the random numbers. So all I need to do is to run knfunc create, and I need to name my function. So I will name it random. And okay, let me just show you the help for the create command. As I was talking before, each function can be triggered either by HTTP or events. So we need to specify that we are creating the function. Default version is HTTP, and then we need to specify the runtimes. So the node runtime is default one, but if I want to develop the application in different runtime, I need to specify it in the command line. So knfunc create random, and I will create it in the node runtime, and it will respond to HTTP, so I don't have to do anything like that. As you can see over here, my project was generated. It's a template. As you can see, it's a pretty standard node project. So I have some package JSON with dependencies, and then I have index.js file. This is the important stuff. So basically, this is the place where you need to put your business logic. And only thing that the function needs to do is to export the actual function that needs to be invoked. In this case, the invoke function is being called. It is handling differently post request or get request. So let me just delete this one, and I will quickly just put the function implementation to save the time. So as you can see, all I need to do is return some random number and export this function. To deploy this function, all I need to do is to run knfunc deploy, and I specify that I want to deploy my random function. What's happening right now under the hood? So we are calling the build packs to analyze this application. It finds out that it is node application, so node builder is running, and it will produce a container with your node application, and it will get deployed on OpenShift as a Knative service. So as you can see, the image has been built. Now it has been pushed to the registry, and now then it has been deployed on OpenShift. Before we look at the application, there is one important aspect, which is this func.yaml file. which holds basically the configuration of our function. So over here we can see that the image that was produced by this function, image digest, the trigger type. This is the builder. So it was the node builder was used for the build packs. And over here we can specify environment variables, or later we can specify secrets, etc. that should be used by the service. As we can see, the function was deployed as Knative service. So I can curl this. And we can see that it returns random numbers. So this was very simple function triggered by HTTP. And Roland, I'm not sure if you want to continue with the eventing part, so that we can show the rest.
Yeah, sure. So actually, let me jump over. So actually, thanks a lot for the function. So this is really the new thing. So it's worth mentioning that this is not Knative. This is on top of Knative. This is done as part of OpenChef Serverless. We are working together with the upstream community to find a solution for this function part, which allows for building stuff. But I think this is worth to keep in mind that it's just part of. But actually, you can if you go to the open upstream project at Bozone, then you can still use it with Knative, of course.
Yeah,
with upstream Knative. So let me share my screen again. So share screen. Oh, sorry. So here we go. Okay. Yeah. So actually, we jumped over the eventing part because I think it was important to see this function thing in action, because this is really amazing to see how you can build stuff and directly also not only deploying but also running and creating things. But let's talk about eventing. What's Kinetic Eventing actually? So this is really about a universal description delivery mechanism for events. And as Zbigniew mentioned, it's based on cloud events. So this is one of the data standard for events, and cloud events itself is a CNCF standard. This is important. So it describes more or less the format how events, so the envelope of these events, how they are transported. But the payload itself can be arbitrary data. So it's just about that you have really a common way of set of headers. You have different transport protocols that you can use for cloud events. But it gives you kind of open standard that you can connect to your eventing infrastructure. And this eventing infrastructure in Knative is centered around the concept of channels. There are different backends for these channels, so that you can have, in the simplest case, you have an in-memory channel, which allows you to transport your events through in-memory things. But of course, it does not have any guarantees for your event delivery. You can use also Apache Kafka for the backend. But also other systems. Then actually there are two other. The channel is one of the core concepts, and the other two concepts is a source and a sink. The source is actually the way where the event comes from. This is how you integrate your eventing sources into the system. And actually for Knative, a source is more like an adapter. It's not really the origin of the event, but it's more like the part that translate a custom event format into the cloud event format. This is the kind of way how Knative event sources typically work. And then these sources, these events that come out of the source are routed to a sink in some way. And before we talk about the routing, let's briefly talk about the sources. So it's there are, as I mentioned, they are kind of adapters, but of course they can also create events on their own. They are typically declared by a custom resource. So every source has also an own custom resource type or custom resource definition. And this is evaluated by a source-specific operator in the backend. And then you connect this event source to the sink. And then every time an event occurs for this source, then the event is put into the sink itself. What sources are available? So actually there are 4 sources that can come out of the box together with Knative. So every time you install Knative or use Knative, you have these 4 sources available. There's a very simple source, which is the ping source. You guess what it does. It just emits cloud events periodically after a timetable or scheduler. It's just a cron expression. API server source, which just converts events that come from a Kubernetes API server into a cloud event and then moves on to the sink. You have two general purpose kind of sources. So the sink binding is kind of a source. So you can view it as a source as it connects an arbitrary pod to a sink. The same is for a container source. But beside these out of stock sources is really that you have also custom sources like for GitHub, Kafka source, or also more general purpose sources like a Camelot. So Camelot is another technology. It's based on Apache Camel and Apache Camel K. And this allows you to reuse all the Camel component, not all, but a considerable set of Camel components as sources. So if you don't know Camel, don't worry. So actually the Camel is an enterprise application integration framework that allows you to connect to different external systems. There are around 300 these kind of components or connectors, if you like to call them. Like you can connect to S3, AWS, you can connect to FTP, to all of these kind of external systems. And the Camelot binding allows you to transform these Camel component generated events into cloud events. So yeah, let's go quickly of the way how you can connect such a source to the service. The service we already know from Kinetic Serving, but actually there are three main ways how you can connect a source to a service. The first one is a direct way. So you connect directly the sink, which could be a Kinetic service, to the source so that every event that comes from the source goes to the service or to the sink. Of course, this has some drawbacks because you don't get any advantages from a messaging system. You just feed it in. So there's no queuing support. You don't have support for back pressure. There's no, when the source goes away, you might miss service. When the sink goes away, you might miss events and so on and so forth. So this is really only just for testing, I would say. A more advanced way to do these things is to leverage a channel. So you can have a source. So a source can push events into a channel, and then your sink connects to the channel via subscription, which is also CRD. So everything what you see here on the diagram are CRDs or custom resources. And so you can build up arbitrary complex event topologies with that. Of course, this can get confusing. So there's a third way how you can do that, which is leveraging a broker. A broker is, I think, the most advanced concept how you can connect stuff together. Again, you have a source which feeds into a broker, and then the sink also subscribes, but not with a subscription, but with a trigger to the broker. And the benefit of a trigger is that it also allows you to provide a filter so that the sink only gets events of a certain type that the filter filters on. So in this picture here, the orange events are going to the upper sink, and on the lower hand side, there the green one filtered here. So this is also easy way how you can create an eventing topology. And of course, a sink can also return a cloud event in this case. And if this is the case, if the return value of the sink, which is typically also used via HTTP, is a cloud event, then it's feed back into the broker and gets rerouted again. So in that way, you can really make a very complex topologies like that.
Roland, just a quick question around that. What could yourself or local Spinnick there give an example of where would you use eventing in the real world? What would a real world scenario look like? What sort of events would trigger this, for example?
With triggers, for example, is we had a demo for that. Actually, unfortunately, not enough time. Example would be, let's assume you have an API server source which emits all the events from API from the API server of Kubernetes. But then you have a sink that only wants to react on events that are about deleting something or adding something or modifying something. This can be done by specifying a trigger, a filter expression to say, okay, I'm interested only into this delete events. And then it also only get these delete events and can do, for example, some cleanup stuff. So you could imagine a sink that is there, sitting there, looking for delete events, and then because you need to make some custom cleanups for that. Of course, there are other extension mechanisms for Kubernetes that can do that, but yeah, in this example, this could be happening.
And maybe Roland, I can show the Telegram demo, which is like very quickly show all these benefits. It could be like in a couple of seconds. So if you let me share my screen. I can.
Yeah, you can do, but I think we're nearly out of time. I'm not sure how much we.
I think we've got a little bit of extra.
Well, yeah, go ahead and share it, and in the
Yeah.
meantime, I'm going to give you guys some questions.
Okay.
Okay, so go ahead.
Go ahead.
Okay, so let's say you were asking about some real case scenario. This is not such a real case, but basically, imagine that I'm in a Telegram conversation with some Telegram bot, and I'm chatting with this bot. And once every time I set a message to this bot, the message gets analyzed. And if there is a photo in this message, there is done some analysis on this photo. And if there are some faces on the photo, I will get number of the faces and the people emotions, and we'll try to make a guess on the age of the persons. So we can easily implement this with Knative service and the functions. So if we look at this developer console, OpenChef developer console, we can see that on the left side we have Telegram source. This is the KMLK Telegram source. It basically listens to the Telegram conversation, and it is sending every message to the Kinetic Eventing broker, which is the component in the center. And then we have three functions, which are Kinetic services connected to this broker. The first function receives the Telegram message, and if there is a photo in the message, it will respond with another cloud event back to the broker. Second function will take this cloud event with the photo. It will do the analysis and reply back to the broker. And then finally, a responder function will take this final result from the analysis, and it will respond back to the Telegram chat. So let me just quickly show it to you. So as you can see right now, the functions are scaled to 0. So I will just type hello to the Telegram bot. And we can see that the Telegram source send the cloud event to the broker, and the receiver function receives the message, but it doesn't find any photo in the message. So it responded that there is no photo. And our responder function responded back to the Telegram chat with this nice message. So actually, let me send some photo. As you can see, I have some prepared photos in here. So I will send it to the conversation. And this time you can see that the photo was analyzed by the first function. So the second function, the processor function, basically does the analysis. In this case, it is calling Microsoft Face API in the cloud, and responding back to the broker with the cloud event that is holding this data. And the last function basically took the cloud event and responding back to the chat. So this way you can see the event flow through the system. So it is all happening through the broker, and the last aspect is that these lines are the connections to the broker, and with each trigger you can specify the filter. As you can see here, we are filtering on the type of the cloud event. So each cloud event has some specific type. So this way we ensure that each function just take the specific cloud event with a specific type. So I hope that this gave you guys some.
As you have seen, the benefit really is that only those components are running that are really needed. I think this is one of the big things, is that if you, for example, have 1 million of text messages without any image, the image processing thing would never pop up because it doesn't have detected any image like that. So, and I think this is one of the benefits of this eventing setup.
Okay.
Yeah.
Are you all ready for more questions?
Yeah, sure.
Cool. So another question actually we got from two different viewers is logs. If you need to examine logs from say triggered functions, where do those logs go?
Yeah, so these logs are just logs coming from a pod. So actually this happening in the pod logs. And of course, you have techniques how you can collect all these pod logs into a central system where you can collect all these logs and then examine them. So actually it's the same question how you can collect logs from pods from regular applications. So there's no difference between serverless logs and regular logs. So yeah, you can also, of course, look directly into the logs, but as you have seen, that you have this kind of very dynamic way that things scales up and down. So it's really highly recommended that you collect these logs in a controlled logging subsystem like Logstash or something.
Anybody feel like comparing Knative with OpenWhisk, which is not a name I've heard for about a year?
Yeah, sure. Yeah, actually, I can try it. So actually, yeah, OpenWhisk is really about out functions. OpenWhisk is not really container based, and so you can deploy functions. You have a runtime behind that, and the benefit, not the benefit, actually, what OpenWhisk really can do, as far as I know, is really they have kind of a pool of workers that are really hot all the time. So they're really optimized for cold start time. So you can really directly deploy that there. But of course, you cannot run arbitrary workloads. You cannot choose your programming language, like let's say. Or you even, for example, with serverless also, what could be possible theoretically is really that you can migrate your old applications to a serverless model by just putting them into a container image. But of course, there are some constraints, and something needs to be. So for example, your applications need to be stateless, but theoretically, this is of course perfectly possible. But for OpenWhisk, you have to adapt to the OpenWhisk model and to really to change even your application there. So this is not my brief understanding.
Yeah. The benefit of OpenChef Serverless is basically that you can have both functions and both serverless containers on the same basically infrastructure, and you can handle them the same way.
Okay. We've actually got another one. So one of our viewers, while you've been doing this presentation, they have an OpenShift cluster, and they have tried to install serverless on their OpenShift cluster. I think it's actually OKD, because they said they tried to install Knative, and it's not showing as ready. Do they need to do something else?
Really? No, this is then a bug, I would say, because actually this is super easy to install. Actually, we could have shown this out in a demo within 2 minutes. Actually, this is something you go to the operator lifecycle manager, to the catalog, you select OpenShift Serverless, and then you have to then you have to follow the instruction there, of course, and you need to create one of Knative serving resource, I think. But actually, it should be all very well documented, but I don't think there are some extra magic hidden step behind that.
Okay. One of our community members here wanted to know when Kafka Broker is coming to OpenShift Serverless. I thought it was already there.
Yeah. So there are two ways. So actually, what we already have is a broker that is based on Kafka for the backends. Actually, on a Kafka channel. So the broker itself. So we have the benefits of Kafka there. But there's also not only plans, but actually there's active work ongoing to have a dedicated Kafka broker, which really does not need to have a channel in between. So you save one translation step, so to say, in between. And but I cannot give any ETA for that, except that it's really on the horizon, so to say.
Yeah, and 2 weeks ago, a week and a half ago, we released Serverless 1.14. That's now got the Kafka plugin included in this as well too.
So actually we have Kafka GA for OpenShift Serverless for the channel, but there are still working going on. So actually we already can provide Kafka as a backend system for channels and also as a source. So actually we also can use a Kafka cluster as a source for events that you may just pick up messages from topics and convert them to cloud events and move them on into Knative.
Okay. And one last question, and this is the hard one. Knative roadmap. Like, when are we getting to 1.0?
Yeah. Ooh. That's a hard one, really. that's true. So actually, I can maybe quickly describe. So actually, there's no really an ETA for that, but I can describe the process, how we try to reach to 1.0. At the moment, and actually I think yesterday was a TOC meeting, and we agreed on a set of criteria that needs to be fulfilled to get to GA. So we set the GA barrier, like, for example, having 80% code coverage on every component. This is one of them. And others, and we want to release eventing, serving, the client, everything from Knative at the same time. So that we have one coherent Knative release for 1.0. And actually we have the check mark. We will check everything there, I think we are confident that many of the requirements are already met, but actually we have to really go through them. And if this is done, then then 1.0 is not so far away. So I would say even so at least in this year for sure. So, but my gut feeling says okay, could be summer as well. But yes, don't take me for granted. So this is just my feeling. But the process really, we're going now through the criteria. We have no real rush. We wanted to have a super solid 1.0 release that really everybody can rely on. But actually, you see that Kinetic itself is already super stable because it's the foundation of many products out there already. It's like OpenChef Serverless. So you get all the GA benefits already if you decide for OpenChef Serverless, even if you're based on a non 1.0 version. But actually, the API versions are already V1. So actually, yeah. So it's for us, it's ready to just jump over this last hurdle.
Okay.
So
and with that,
sorry,
we're actually out of time.
Yeah. So thank you, everybody. Remember, we are in the CNCF Slack, the number 6-KubeCon-Red Hat. Feel free to go in there and ask your questions about Knative. I'm sure someone in there can help us get you to the right answers. So thank you very much for all your questions, though.
Yeah, or in the Knative Slack, and we will see you at the next office hours or on CNCF Slack. Thanks so much, team.
Yes, thank you very much. Wonderful demo, and thank you, audience, for participating. We really appreciate it.
Thank you.
Thanks. Cheers.